I'm Anil Kumar sharing with you some difficult questions on factoring. Now these questions are very good for IB students and AP Calculus students to practice. We have 6 polynomials here. You need to factor them. A, 4a square minus 9 minus 2ab plus 3b. B is x square minus 9y square plus x minus 3y. C, 4a to the power of 4 minus 16a square plus 9. D, 4a to the power of 4 plus b to the power of 4 plus a square b square. E, 4 plus a square, and E is a to the power of 6 minus b to the power of 6. If you really look into them, these 3 are unfactorable. So you really cannot factor them using the techniques which you have learned so far. The other 3 are not so difficult, but they require application of the OR techniques twice. That is all. So the other 3, they require the techniques twice. So you need to factor kind of twice, right? Let me write like this to get the other 3. So that is how these 6 examples are. Once you do them, you should be in a position to do most difficult questions in your test paper on factoring. So let me take the easy ones first. So A is 4a square minus 9 minus 2ab plus 3b. You can always pause the video, answer, and then look into my suggestions, right? Now, what you notice here is that the first 2 terms are difference of square, right? These 2 are difference of square. Now, in this exercise, difference of square is the key thing. So you could always do this by using a square minus b square equals to a plus b times a minus b, right? So 4a square minus 9, let me go one more step and then I'll write it. Could be written as, let me write this as 2a whole square minus 3 square. So you can now see the difference of square, right? In the second half, we can always take b as common. So we get 2a minus 3. Now here you see 2a minus 3 factor. So you could write this as 2a minus 3 times 2a plus 3 minus b times 2a minus 3. Now 2a minus 3 is a common factor in both the terms. We get 2a plus 3 from the first and minus b from the second. So you could always rearrange this and write this as 2a minus 3 times 2a minus b plus 3. Okay? So that is how you can factor a. Now exactly similar technique can be applied to factor b. So I'm sure you learned this technique now. So let's apply it again. So we have x square minus 9y square plus x minus 3y. I can always write this as x square minus 3y whole square plus x minus 3y, correct? And that is equal to x minus 3y times x plus 3y. And here we have x minus 3y. Now you can take x minus 3y as a common factor and you get x plus 3y plus 1. So that is your factored form, correct? So you could write this as x minus 3y times x plus 3y plus 1. Do you get it? Perfect. So these 2 are simple. Now let us see how to do the others. this a to the power of 6, b to the power of 6. Let me take that first. So we'll go with the green ones first, and then we'll tackle the red ones. Okay, so here is a to the power of 6 minus b to the power of 6. Now we'll apply here this formula, which is a cube minus b cube formula. It could be written as a minus b times a square plus ab plus b squared. We can also apply a formula related to difference of square, b, right? Okay, so that is a minus b times a plus b. So combination can be applied. So that means we have two ways of factoring this particular difference of square. You should say binomial. So one way could be that I could write a to the power of 6 minus b to the power of 6 as equal to a square minus b square. Let me write this as cube first, right? Or I could write a to the power of 6 minus b to the power of 6 as a cube whole square minus b cube whole square. So both gives you, the same power, that is 6, right? And both may give you the same result. What do you expect? You expect the same result, right? So either way, you could do this particular question, correct? So let's try. So if I do difference of cubes, I'll apply this formula first. So I'm doing a minus b. For me, a is a square, right? So a square minus b square. The term inside times square of these, a to the power of 4. First we'll write product here, which is a square b square, and then we'll write the last term, b to the power of 4. Now that part is not factorable. However, this part is. We could write this as a plus b times a minus b times all this, which is a to the power of 4 plus a square b square plus b to the power of 4. Correct? Next one here, what we can do is we'll do difference of square first. So we get a cube minus b cube times a cube plus b cube. Do you see that? So you get difference of squares. Now these are your terms inside the bracket, which will be used as a and b. Now a cube minus b cube can be written as a minus b times a square plus ab plus b square, and a cube plus b cube could be written as a plus b times a square minus ab plus b square. So we get that form now. So that is to say a minus b times a plus b times a square plus ab minus b square times a square minus ab plus b square. You get an idea, right? So you can see that there is some kind of difference in the two end results, right? So what you should do normally is that you should follow this particular technique of factoring. So what you also realize here that this portion could have been factored, correct? I could write this portion as product of these two. Do you appreciate that? Right? So I could write this portion as product of these two, correct? Now we'll see in one of our examples how do we do that. So we have a basic example which is kind of like this. Let me show you here. This is part D, right? So it's kind of like this, not exactly, but kind of like this. So we will see how to factor that in one of our examples, but you should understand that you will actually get same result, right? Okay, let's move on. So now we are taking care of unfactorable. So these are, I say, unfactorable. Okay, now let's see how to factor them. So let's rewrite this to understand the issue. We have 4a to the power of 4 minus 16a squared plus 9. As you can see, 4a to the power of 4 could be written as 2a squared whole square, right? 9 could be written as 3 square. Now in the center, if I have 2 times this, that is to say, if I have 2 times 3 times 2a square, then I could easily factor this portion as a plus b whole square. You get an idea, right? But what I have here, 2 times 3 is 6, 6 times 2 is 12. I do not have 16. I have 12 there, correct? So that is the kind of strategy which we are looking for. This actually is 2 times 2, 4 times 3 is 12. So we have here 12a square. Is it okay? Well, we could have worked with negative also, since this is negative. But I have negative 12a square. Do you get an idea? So this is kind of key to understand, basic key. That gives you an idea. So the idea here is, let's get back to our original question. We could write this as 2a square whole square. Instead of 16, I'm writing this as minus 12a square plus 9, and the remaining minus 4a square I write separately. So what I did here was, I split this 16 into 2. One is minus 12a squared, the other one is minus 4a squared. Do you see that? So these are those two. Now, these three could be combined, and we could write them as 2a squared minus 3 whole square, and we have minus 4a square. Do you see that? Now that is as good as 2a whole square. So I could now factor this using difference of squares. Perfect. Now this could be now factored as x square minus y square equals to x plus y times x minus y. So I could now write this as 2a. So this minus that. So 2 square minus 3 minus 2a times 2a square minus 3 plus 2a. You get an idea. So I have factored it. Isn't that cool? So we have now factored this, just rearranging. So we can get this as 2a square minus 2a minus 3 times 2a square plus 2a minus 3. You get it? So that is how you can actually factor unfactorable polynomials. Have a good look. So we're going to apply similar technique to factor the next one, which is 4a to the power of 4 plus b to the power of 4 plus a square b square. Now you know the technique, so I'd like you to pause the video, answer, and then look into my suggestions. Now let us see how to factor this one. So what we are given here is 4a to the power of 4 plus b to the power of 4 plus a square b square, right? Now we could rewrite this as 2a square whole square. So that is 4a to the power of 4. Now b to the power of 4, I could write b square whole square But let me rearrange it. I'll write now first this term, which is a square b square, and then I will write b square whole square. Do you see that? Now that could have been a perfect square provided we had 2a square b square here. Perfect. What we can do actually is we can just add and subtract a square b square. So we call this a method of completing squares, kind of. Right, so what we are going to do now is to apply a new technique which is kind of complete squares. How are we going to do it? We're going to add a square b square and also subtract a square b square. So in fact we are adding 0. So we're not changing our polynomial given to us, right? So, but this helps us. It helps us in making this as 2a square b square. So what we get here is we get 2a square whole square, and this could be now combining these two terms written as 2a square b square plus b square whole square, and we have minus a square b square. Does it make sense to you? Correct? Now, these three terms which are right there for us could be combined and written as a perfect square. So we are going to write this as 2a square plus b square whole square, correct? And we already have a difference of square term like this. Treat this as like this, a plus b whole square. Now you can apply difference of square. That is, we know x square minus y square is product of their sum and difference. So let's apply this formula, and what we get is a factored form. So we have 2a square plus b square minus ab times 2a square plus b square plus ab. Does it make sense to you, right? You could always rearrange them. You could rearrange and write them as 2a square minus ab plus b square times 2a square plus ab plus b square. Correct? So I hope you remember in difference of when we had 6 powers, we got this kind of a factor at the end. Perfect? For this kind of a trinomial. Correct? So that is how that could be factored. Now here is the last question of our factor challenge. We need to factor 4 plus x to the power of 4. You have learned that if you kind of sketch it, what graph do you get? We'll get a graph which will be like this. Opening upwards with minimum, absolute minimum at x equals to 0, right? So if this is x-axis, this is y-axis. Here we get at 4 the local minimum. Since there are no x-intercepts, it cannot be factored. That is what we learned, and therefore we say it is unfactorable. Is that okay? So using normal techniques, you indeed cannot factor it. So again, we are going to apply the techniques which we have learned to factor this. You can see that we can rewrite this term 4 plus x squared as 2 squared plus, x to the power of 4 as x squared to the power of 2, right? So that is x to the power of 4, correct? So we could write like this. What we really need here to factor is a term 2ab, right? A plus b whole square is a square plus b square plus 2ab. So what we need here is 2 times 2x squared. This is what we need. So we can add and subtract this term 2 times 2x squared. Does it make sense to you? That makes it factorable. So when you combine the first 3 as we did in last two examples also, when you combine the first three, you do get a perfect square, and you could write this as 2 plus x square whole square, correct? And you have here minus 4x square, which is 2x whole square, right? So which is to say, we again have a difference of square term, which is kind of like this. And now you can factor. You can write this as 2 plus x square minus 2x times 2 plus x square plus 2x. So finally, you could factor it. You can always rearrange and write this as x square minus 2x plus 2 times x square plus 2x plus 2. That is how you factor unfactorable binomials or trinomials or terms, four terms, right? So that is how we could do it. So I hope you understand and appreciate the technique. Since we have applied it so many times, you must have perfected it by now. Feel free to write your suggestions and comments. If you like, and subscribe to my videos, that'd be great. Thank you and all the best.